Next example is a factorial. Again, factorials and exponentials are situations where you really want to use the ratio test. So I'll take a look at this and I'll compare, because I don't see anything else that I'm going to be able to work with. The limit as n approaches infinity of n plus 1 is what I'm plugging in there, so I'll do n plus 2 factorial over 3 to the n plus 1, all divided by n plus 1 factorial over 3 to the n. Okay, so the new equation over the original equation. Set up the limit one more time, and then sandwich. It's nice whenever you have those fractions on top of each other like that. So we'll go n plus 2 factorial over n plus 1 factorial. And then you still have 3 to the n here and 3 to the n plus 1. Now, I've talked about this before, but just a reminder about your factorials. N plus 2 factorial, remember you're subtracting 1 every time. So that's kind of what your pattern would look like, and you would continue until you got to 1. If you started at n plus 1, it would look like this. You would keep going. So these always end up reducing, so that's all you have left. Right? And then the 3 n plus 1, right, you're going to end up, remember, if this was a 4, and that was a 4, then we would have 3 to the 5th on the bottom, so you end up with 1 extra 3. So when I rewrite my limit all simplified, I end up with n plus 2 left on top and a 3 left on the bottom. Well, if n is approaching infinity, the numerator is growing much faster than the denominator. This is basically infinity. Now, the temptation here is to look at that and say, oh, like, it diverges because of an infinite limit. Okay, recognize the test that you're working with. It converges, or it diverges because infinity is greater than 1. Remember, the test is it greater than 1 or is it less than 1? And if it's greater than 1, then it's going to diverge. If it's a less than 1, it's going to converge based on the ratio test. So just make sure you are familiar with that and you don't just make assumptions. So we'll say the series diverges by the ratio test. But it's because we're comparing it to 1, not just because, oh, the limit happens to be infinity, because we're comparing it to 1. Okay. The algebra does get a little tricky with the ratio test, so there are a couple on your homework that get a little stout with the algebra, but I think you guys can handle it. Just be careful with those steps and work together.